We're going to start with cosecant and secant. Okay, so if you will recall, hopefully from Unit 1, cosecant is the reciprocal of sine. Okay, so the cosecant function is the reciprocal of the sine function, and secant is the reciprocal of cosine. Okay, so you can see that's why they have it written as secant is 1 over cosine. I'm going to put the abbreviations in here as well. That's okay. Okay, so remember, secant is SEC, cosecant is CSC. You don't need to memorize all of these attributes, all the properties of them. You really just need to know what the graph looks like and be able to identify it in a question. Okay, so what I'm going to start with is I am going to sketch this sine curve here on the cosecant graph so that we can kind of compare the two, because I think that will help you to be able to determine the difference between cosecant and secant, because they're very similar, just like sine and cosine are very similar. So remember, sine for one cycle goes through the origin up to 1, 0, -1, 0. Okay, so here's a cycle of the sine curve. Okay, and then it could go in the negative direction as well. Okay, so I'll go ahead and sketch that. Okay, so this is the sine curve, the dotted green line here. You'll notice that everywhere where the sine graph goes through the x-axis where it was 0, what's happening on this cosecant graph at all of these x values? What do you see at all of those x values? And it's not drawn as a red dashed line, but there's one here as well on top of the y-axis. What are those vertical red dashed lines? Do y'all remember what those are called? Yes, asymptotes. Good. Okay, now why is there an asymptote? Why are there so many asymptotes in this graph? So let's think about this. Okay, wherever sine is 0, cosecant is the reciprocal function. So if I have 0 over any number and I want the reciprocal, it becomes some number over 0, right? And we cannot divide by 0. Okay, so that's why those asymptotes are there, because the reciprocal of 0 is undefined. And on our graph, we show that that value is undefined with the asymptote. Does that make sense? So where the sine value is 0, cosecant is undefined, so there's asymptote at all of those values. Now, what's the reciprocal of 1? Okay, so like here, sine is 1. What happens if you have 1 over 1 and you flip it? Still 1 over 1, right? So notice they share this point. That point up here at 1 is part of the sine curve and the cosecant curve. Same thing with the points at -1. Okay, so those points are shared. It's like those curves that are curving down in or up into each other. It's oscillating back and forth, right? So this is curved down toward the x-axis. It's just flipped up to open up. And this one below the x-axis that was curved into the x-axis is flipped down to open down. Can y'all see that? Okay, so those curves are just alternated from going in or opening in toward the x-axis. They're opening away from the x-axis. Okay, so those are flipped out, but they share the points at the 1s and -1s. And where sine had an x-intercept, there's now an asymptote. Okay, so you hopefully would notice here from this asymptote at the y-axis, okay, how far do I have to go over before the graph starts repeating itself? Anybody see? 2 pi, right? Because I've got an asymptote and then the curve opening up, asymptote, curve opening down, asymptote, and so next would be a curve opening up again, right? So that's when it would start repeating. So 0 to 2 pi, that's my period, 2 pi. So when we look at the graph of secant, I'm going to do the same thing, and I'm going to draw the cosine graph on top of it. So cosine starts at a high point on the x-axis, or excuse me, the y-axis. Here's the cosine curve. Here. Okay, and you can see everywhere that cosine went through the x-axis, that is now an asymptote for secant. Everywhere that cosine was at 1, secant's at 1. -1, same thing. So they share those points. And again, it's just like those curves are flipped to open away from each other instead of towards each other. And so it's got the same period. Now the period was measured from a different spot. Okay, this asymptote is at -pi/2, and this one's at 3 pi/2, but that's still a distance of 2 pi for the period. Okay, so those are so similar. It is very common to mix secant and cosecant up. So you really have to remember cosecant is the reciprocal of sine. Sine is 0 at 0. So there's going to be an asymptote at 0 for cosecant. Okay, the asymptote for secant is going to be at pi/2. So you can see here it's at 0 pi, 1 pi, 2 pi. And here it's at pi/2, 3 pi/2, and be at 5 pi/2. Okay, so it's the difference is the location of the asymptotes. It's like this has just been shifted over. Just like sine and cosine are the same, just shifted over. So far, so good? Okay, so let's look at this example. We're going to go through what we've been doing with sine and cosine functions to graph them. I'm not going to do the full-on table because this has just got one simple transformation. I think by now y'all have kind of gotten the hang of graphing sine and cosine. That maybe we don't need to do a table of values every time, but let's just identify all the pieces. What is A? Okay, so A is the coefficient in front of the trig function, which here there is no coefficient, so it's an understood 1. So that tells me that there is no vertical stretch or compression. Okay, it's going to be the same height as the parent function. Okay, what about B? What is the B value here? The B is, where do you find B in your equation? Okay, yeah, it's the coefficient in front of x being multiplied by x. So it could be inside or outside the parentheses here between the trig function and the x. Okay, but there's nothing in either spot, so that means it's an understood 1. So that means there's been no horizontal stretch or compression either. Okay, so the height and width of the graph, that's all going to stay the same. Okay, but what is that plus pi/2 inside the parentheses with the x? What is that doing to the graph? That is a horizontal shift. What direction? Left. So it's the opposite sign that you see here. So the horizontal shift is actually negative pi/2. Okay, that means it's going to the left. Okay, is there a vertical shift? No, if there was a vertical shift, there would be a number added or subtracted on the outside of the parentheses, and there isn't, so there is no vertical shift. Okay, so this is what we know. No stretching or compressing vertically or horizontally, no vertical shift, just shifted to the left pi/2. Okay, so I'm going to write out that description. Because if you sometimes may be asked to just describe the transformation. So I would say this is a horizontal shift left pi halves. So the cosecant parent function, don't draw this quite yet because I'm going to move it. The cosecant, that's the reciprocal of sine, which sine starts at 0. So our asymptote is here. But I want to shift it to the left pi halves. So it's going to, oops, not the graph, the asymptote. Okay, so I'm using that asymptote right there. This is like my starting point, if you will, okay, because I've shifted left pi halves. That's my horizontal shift. How far apart are the asymptotes on secant and cosecant functions? They're 2 pi is the period. Okay, but that's not how far apart each asymptote is, right? Okay, they're pi apart. So if this is at negative pi, I would go to positive, or negative pi halves, excuse me. I would go to positive pi halves. Okay, so the distance between those, okay, that's how far the spacing should be between each asymptote. Okay, so you can see that's 4 grid lines. So over another 4. Is that what? That's for every secant or cosecant graph that has not been horizontally stretched or compressed. Does that make sense? Okay, it's going to keep that same width between the asymptotes as long as it hasn't been horizontally stretched or compressed. Okay, now in between. So this is the one I'm considering my starting one. Okay, to the right, cosecant is supposed to be above the x-axis. Okay, and then from there, you know, it alternates. So this would be the graph of y equals cosecant of x plus pi fourth, or excuse me, pi halves. What does this graph now look like? Yeah, now it's the secant graph. Okay, the secant graph is the cosecant graph shifted pi halves in either direction. Actually, not in either direction, because if I had shifted it over, the upper one would be here and the lower would be here. Okay, so this is now the same as secant. So secant is just the cosecant graph shifted to the left, pi halves. So far, so good? Okay, if you need a refresher, you want to write somewhere your equation for what are we talking about for this A, B stuff? So remember, it's A, and then your trig function. That could be sine, cosine, cosecant, secant, whatever. And then, oops. And then B, oh my gosh, times x minus the horizontal shift plus D. Okay, so when the B is factored out, your horizontal shift is just the opposite sign of what you see there. Okay, so if you've forgotten where these values are coming from, that's what we're using. All right, now that's cosecant and secant. What's another trig function we haven't talked about yet? Tangent. Okay, so tangent, we learned back in unit 1, tangent is sine divided by cosine, right? So if we know the sine values and the cosine values, we can figure out the tangent values. Okay, now, we talked about earlier how you can't have 0 in the denominator of your fraction. You can't divide by 0. So since cosine is the denominator of the tangent function, that means if cosine of x is equal to 0, tangent is going to be undefined. Does that make sense? So what happens on the graph when it's undefined? What's going to exist on the graph where the value is undefined? What were those vertical dashed lines called again? Asymptotes. Okay, so wherever cosine of x is equal to 0, there are going to be vertical asymptotes on the tangent graph. Okay, so vertical asymptotes wherever cosine of x is 0. Now sine is the numerator. Okay, when your numerator is 0, that's okay. What's 0 divided by anything? So when sine of x is 0, tangent of x will be 0 also. Does that make sense? So these two graphics here are just to help you visualize that. So you can see this has the cosine wave behind it, that like faded wave. Everywhere that it's 0, notice there's an asymptote. But everywhere that sine is 0, the graph exists. It's going through that point. Vertical asymptotes, yes. Asymptotes. All right, now. Oops, that's not what I meant. I'm going to make this graph a little bit bigger. All right, so you can see on the tangent graph, the asymptotes are at all the values where cosine would be 0. So those asymptotes are at the same place as the secant function's asymptotes, aren't they? Because when cosine was 0, secant was undefined. And again, when cosine is 0, tangent is undefined. So tangent and secant have the same asymptotes. Does that make sense? Okay. Now, the values for sine being 0, those points exist. Those are your x-intercepts of these curves. Now, this is not that U shape and alternating, opening up, opening down, opening up, opening down. These, in between each asymptote, they all have the same identical curve. Okay, it's continuous in between each asymptote. It's increasing from left to right. Okay, and then in between the next set of asymptotes, it's the exact same curve, right? No change. So what does that mean for the period? In secant and cosecant, you had to go 2 pi before the graph started repeating itself. Because there was a curve opening up, and then an asymptote, and then the curve opening down, and then another asymptote before it repeated. Now, you don't, there's no alternating up, down, or direction. Okay, it's just between each set of asymptotes is the exact same curve. So you're only having to go pi radians before the graph starts repeating itself. Does that make sense? So that means when I'm writing an equation or I have an equation and I want to know the period, instead of the period being 2 pi divided by b, like it was for sine and cosine and for secant and cosecant, it's going to be pi divided by b because the parent function period is just pi. You'll follow? All right, so let's try this next example. What is A? Understood 1. No A value, so it's understood to be a 1, which means there's no vertical or horizontal, or excuse me, vertical stretch or compression. What is B? B is the 2. So that means there is a horizontal stretch or compression. Is it going to be a stretch or a compression? Okay, back in part 1, when we looked at B values, the period values for sine and cosine functions, we talked about how when the B value is greater than 1, that's actually going to compress the graph. It does the opposite of what you would think, because that's what inside we do the opposite, right? So this is actually going to compress the graph by 2. If you're compressing by 2, that means it's getting half as wide, right? Another way to think of that, when we made the table of values, we had our critical points would be titled with 2x. How would I work backward to get x alone? How would I get rid of that 2? I would divide by 2. Okay, that's what you're doing to your period. You're taking the original period and dividing out the b, dividing by 2. So you can see the period is no longer pi, it's pi halves, because it's been horizontally compressed by 2. So again, don't sketch this yet, just watch. Okay, the tangent parent function has asymptotes at negative pi halves and pi halves. Okay, there are no shifts taking place, right? No horizontal shift, no vertical shift. There's nothing added or subtracted inside or outside. Okay, so I'll go ahead and make note of that. So no shifts. The only change is that horizontal compression. Okay, so that's like you're taking your hands and putting them on the outside of your graph and squeezing them together. You're compressing it in toward the y-axis by 2. So it's going to be half the distance it was from the y-axis. So that's going to be at pi fourths. That's going to come into negative pi fourths. Does that make sense? You're compressing it in, and now the period from negative pi fourths to positive pi fourths, that's a distance of pi halves, which is what we said the period should be based on the equation. So that's good. Now the curve in between would go through the origin. Oops. And it's increasing left to right, this graph. Okay, and then it just keeps repeating over and over and over again. So you would see the same curve between all of those asymptotes in the same direction. There you go. That would be the tangent of 2x. So it's twice as narrow. It's horizontally compressed by 2. Questions on that one? All right, last but not least, we need to cover cotangent. So cotangent is the reciprocal of tangent. Okay, so if tangent was sine over cosine, cotangent is cosine over sine. So you're flipping where your asymptotes should be. Okay, your asymptotes and your zeros, your x-intercepts, switch. Because now the graph is undefined where sine is 0, and it's 0 where cosine is 0. Okay, so the asymptotes are now at 0, pi, 2 pi, 3 pi, etc. So the asymptotes are in a different spot. And what else is different about this graph besides the location of the asymptotes? The curve, right? It was increasing left to right for tangent. Cotangent is decreasing left to right. Does that make sense? Do y'all see that? So that's how you can tell the difference between those two. The location of the asymptotes and the direction of that curve. Is it increasing or decreasing? The period is still the same, which that means it's the period is pi divided by b instead of 2 pi divided by b for tangent and cotangent. All right, so that's it for the Unit 2 notes. They're done. Your whole notes packet from part 1 to part 4 should be completed. There's